Today's video is sponsored by WhoMentors.com Incorporated.
Hola Familia, how's it going? My name is Antonio Mendieta, and today I'm going to walk you through another algorithm so that way we can improve our programming skills. Alright, so this is problem 1046, the last stone weight. And the description goes, you are given an array of stones, where stone's index is the weight of the indexed stone. We are playing a game with the stones, and on each turn we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y, with x is less than or equal to y. The result of the smash is when x is equal to y, both stones are destroyed, and if x is not equal to y, the stone of weight x is destroyed and the stone of weight y has a new weight, y subtract x. Okay, at the end of the game, there is at most one stone left. Return the smallest possible weight of the left stone. If there are no stones left, return 0. And here we have a couple of examples. So let's just take a look at both of them. Stones 2, 7, 4, 1, 8, 1. The output is 1, and that is because when we combine 7 and 8, we get the result of 1. So we have 2, 4, 1, 1, 1. When we combine 2 and 4, we get 2. So the array converts to 2, 1, 1, 1. And as you can see, keeps continuing the pattern until we have one more stone left. Now in example 2, we have stones 1 and the output of 1. I think one more example that they should have had is if they had stones 1 and 1, then the output would be 0. Because as mentioned in here, if they are both equal to the same, then both stones are destroyed, and it is possible to have an empty list. So the constraints are anything 1 between 30 for the stone's length and 1 to 1000 for the stone's value. Okay, so let's go ahead and answer this question. So the first thing we're going to do is we're actually going to do the basics, right? Which is combine two stones, return, or then destroy both stones, destroy or remove, right? Both stones. And return a new stone based on, we'll call them stone 1, subtract stone 2. And then of course, if they aren't the same size. Okay. So now that we established that, let's go ahead and create our two stones. Sorry, stone 1 and stone 2. Now we are starting with the largest stones. So right now I'm going to write just some pseudocode to give it value. Largest stone. Then this is also going to be largest stone. We're also going to be removing the stones. We can actually postpone this because the plan here is actually to make this be a function that will return the value of the stone, but will also remove it at the same time. And then return a new stone based on stone 1 subtract stone 2 if they are not the same size. That's just going to be an if statement. stone 1 is always going to be larger, really. So I mean, we could always do this, but just so we can stay consistent with what it says, let's just do if stone 1 is not equal to stone 2. So if stone 1 is not equal to stone 2, we're going to create a new stone, and that is going to be equal to stone 1 subtract stone 2. And the reason why we were doing this is because this would give us a positive number, because if stone 1 is going to be the largest stone at the time, and then stone 2, and then stone 1 is going to be removed, and then stone 2 is going to be the next largest stone at that time, then we want to subtract it from each other in this format. So once that's done, we can actually append or add that stone back to the stones list. New stone. Now, once again, to point out, stone 1 and stone 2 don't actually return any values yet because this is just a function. So let's actually create the function. So step 2 would be get the value of largest stone. So let's create another function, largest stone. So for this function, first we're going to get the largest value, no, the index of the largest value. So it's going to be and we're going to set that equal to stones dot index, then max, and then we're just going to get the max value. Now, once we get the largest value index, we're going to pop it from the list, which will return a value, but also remove it from the list. So let's do stones dot pop. And we're going to return this. Okay, so now just to see that we are in the right track, let's go ahead and print some of these. Stone 1, print. Stone 2, run the code. Okay, obviously we're going to get a wrong answer. But you can see that it returns 8 and 7, which are indeed the largest value in this list. Now let's go ahead and take a look at what we have. Let's see if this function also works. This function, if this condition works too. Stones. As it says here, it should be 24111. Print stones. 24111. Okay, so far we're on the right track. Now the next thing is that we need to loop over this until one stone is remaining. So in order to do that, we gotta put these in a while loop. So while the length of the stones is greater than 1, keep repeating this algorithm. Okay. That looks like it works just fine. And then we want to return the value of the only stone that is left, which will be found in index 0. Let's run it. And there we go. Now we're starting to get positive feedback because we're actually returning the value that they want. Now, for the last thing, right, what if stone 1 is actually equal to stone 2? And once again, that's actually something that we have to look at. So let's go ahead and change our test case. Let's make it that they are equal to each other. Let's go ahead and run it. And as you can see, our print will return an empty list, right? Which makes sense because 1 on 1 would destroy each other. So in order to return the value of 0 when there are no stones left, we will simply do return. We're going to do a one-line if statement, essentially. So return the value of stones index 0 if there are stones. But if there is anything else, like if there is no stones in stones, or if it's empty, just write a 0. As you can see, that is an accepted answer. Okay, so let's go ahead and finish our thoughts here. So continue. And if there are no stones left, continue doing number 1 until there is 1 stone left. And if there are no stones left, return 0. So the big notation of this algorithm is n squared, and that is because even though we only have one while loop here, we also have another method that's being used here that's actually going through the whole list and returning the max value of the stones. So yeah, as I said, this one has a big O of n squared. And there's actually a faster way to do this using data structures and heap. And I will publish that one out soon enough. But for right now, this would give you, let's see, let's go ahead and submit it. So for right now, this is an accepted answer. And I really hope you understand why this algorithm works, and hope that you apply it to your next practice problem. I think the 2 key things here that may not be commonly known is the max, getting the index of the stones, and appending and popping. So if you're not familiar with that, definitely review it. Thanks for watching, and have a nice day.